Good afternoon, guys. Today is the last lecture of design of IC engine component. Okay, we have seen all the theories related to design of IC engine components. Also, we have seen some numericals on the design of the piston, design of the barrel, design of the ring, etc. Today we will also solve some numericals on each bit. Okay. See, first numerical, the single cylinder 4-stroke petrol engine has the following specification. You have given the brake power 7.35 kilowatt. Speed is given 5000 rpm. Brake mean diameter pressure is equal to 0.21 MPa. Bore to stroke ratio means which ratio is given, bore diameter to the length of the stroke. This D by L value is given 0.909. Compression ratio, it is denoted by the CR, this given 6. Determine the bore and length of the cylinder. Okay, we want to calculate the value of the diameter, bore diameter and length of the stroke. How to calculate that both value? First see the given data. Then first we know D by L ratio is given 0.909. Then L is equal to, we will get the one relation 1.1 D. We know the brake power is equal to PBM into capital L into AN divided by 60 into 1000. What is PBM? We want to put this value in that equation. Okay, PBM into 1.1 D L is equal to into pi into D square area. Okay, pi into D square into N. Okay, divided by 60 into 1000 into 4 into 4. If you are solving that equation and putting the value, then you will get the D is equal to 99.06 mm, or we can say the 100 mm, and you know the relation in between the D and L. L is equal to 1.1 D is equal to, you will get the 110 mm. This way you can calculate the bore diameter as well as the stroke length. You know the given data. With the help of that given data, you know the which formula we want to use to solve and find the bore diameter and length of the cylinder. Okay, remember the formula. With the help of that formula, easily you can solve the given numericals. Okay, here is a how to get that 4 pi by 4 into D square into N, area to N. Okay, this value is given. Okay, how to calculate N? N is the number of cycle per minute is equal to 5000 cycles are given. Speed 5000 divided by 2, you will get the number of cycle per minute 2500 cycle per minute. Okay, then next, length of the cylinder. How to calculate the length of the cylinder? You know the compression ratio is given. Compression ratio is equal to, we have seen the formula, swept volume plus clearance volume divided by clearance volume. You know the stroke plus top clearance divided by again top clearance, means stroke length is denoted by L plus top clearance is denoted by the L1. Yes, L1 is equal to top clearance. CR is given 6. 6 is equal to 110 plus L1 divided by L1. If you solve this equation, then you will get the L1 is equal to 22 mm. And length of the cylinder, how to calculate that LC? is equal to stroke plus top clearance plus piston length. Okay, LP value is not given, but we have seen when you design the piston, then there is one relation we have seen. LP is equal to 1.25 d. Put that value is equal to LP, then you will get the length of the cylinder is equal to 257 mm. Okay, this is the answer of the first numerical. Then we will going on the second numerical. The single cylinder 4-stroke diesel engine has the following specification. Which engine is given? Diesel engine 4-stroke. Brake power again BP is given 7.5 kilowatt. Engine speed is given. RPM of the engine is given 1500 RPM. N value. Indicated mean effective pressure 0.29 Newton per mm square. Maximum gas pressure is given 4 Newton per mm square. Stroke to bore ratio, again you have given the L by D ratio is given, okay, 1.35, and compression ratio CR value is given 11.1, and reboring factor is given 3.5 mm. Okay, we have seen in the design of the piston their reboring factor 3.5 mm. The cylinder liner and head are made up of grey cast iron Fg 260, means Poisson's ratio mu value is given 0.25 mm, 0.25. The stud are made up of plain carbon steel 40 ch. S is equal to 380 Newton per mm is given, strength is given. If the required factor of safety is 6, then determine the bore and length of the cylinder liner. Second, the thickness of the cylinder liner. Third, the stress in the cylinder liner. Then the thickness of the cylinder head and the number of size and pitch of the stud. Okay, this value we want to the calculate. We have seen there are two types of the liners, wet liner and dry liner. Then see which is given value. Brake power is equal to 7.5 kilowatt. N is equal to 1500 divided by 2. Then you will get the 750 cycle per minute. Then pressure is given 0.29 into 10 raised to 6 Newton per meter square. Maximum pressure is given 4 Newton per mm square, is equal to 0.8. Then reboring factor C1 is equal to 3.5. Okay, SUT is given for the cast iron material. Then you will get the ultimate tensile strength, okay, 260 Newton per mm square, and mu is equal to 0.25 Poisson's ratio. And for steel, if you have given the carbon steel, then this 40 C8 SYT value, yield strength is given for steel 380 Newton per mm square, and factor of safety is given 6. Then see, one by one we will calculate the bore and length of the cylinder liner. First, how to calculate the cylinder liner bore and stroke? In the last numerical, we have seen that both things, how to calculate the cylinder liner bore diameter and stroke length L and length of the cylinder. Both formulae we have seen. With the help of that formulas, you can calculate the value of D and L. You will get the 135 mm to, and L is equal to 183 mm. And similar way, length of the cylinder liner, you will get the LC is equal to 370 mm. Then we will going on the third number. Determine the thickness of the cylinder liner. How to calculate the thickness? You know the formula. The thickness sigma all is equal to SUT divided by NF. We want to calculate the sigma all, allowable tensile stress for the cylinder liner. Okay, SUT is given 260 divided by 6 is equal to 43.33 Newton per mm square. You will get the sigma allowable. And see how to calculate 4 into 135. Okay, this value is given for the bore diameter 4 into 135 divided by 2 into 43.33 plus reboring factor is 3.5. okay, reboring factor is given, say 3.5, reboring factor is given 3.5, and here is a maximum gas pressure P max, right? Maximum gas pressure is given 4 into 135 means pm into maximum gas pressure into what you have given, boring diameter d 135 divided by into sigma all, okay, plus reboring factor, you will get the thickness is equal to 10 mm. Then stress in the cylinder liner. How to calculate the stress in the cylinder liner? There are three stresses we have seen: circumferential stress, longitudinal stress, and radial stress. Then we will find one by one. First is the circumferential stress. It is denoted by the sigma c is equal to P max into d divided by 2t. Again, see what is the value of P max. 4 is there. In above formula we have seen again same thing. 4 into 135 divided by 4 into 10, okay, to 10, you will get the 27 Newton per mm square. 2t is there, by mistake I have written here 4 for the circumferential stress. This is also written for the longitudinal stress, say P max d divided by 40. Then you will, when you putting the value P max d and t, then you will get the 13.5 Newton per mm square. This is the longitudinal stress. And last is a radial stress. It is denoted by the sigma r. Sigma r is equal to, there is a relation, sigma r is equal to minus P max. Sigma r is equal to minus 4 Newton per mm square. Okay, this value you will get in the stresses in the cylinder liner. Then next, fourth stress we have seen, the resultant stress. Resultant stress. How to calculate the resultant stress? We have seen number of theories. With the help of that theories, you can calculate the resultant stress. Sigma r is equal to, in bracket, sigma c minus mu into sigma r plus sigma t. If you are putting the circumferential stress, then longitudinal stress and radial stress value, the resultant stress, you will get 24.63 Newton per mm square. Then next one, thickness of the cylinder flange. We have seen it is denoted by the TF. TF is equal to, you know the relation, 1.3 T. T we have calculated 10. Then you will get the TF is equal to 13 mm. Then thickness of the cylinder head, TH. It is denoted by the TH. TH is equal to, you know the formula, K1 into D root of P max divided by sigma all H. The material selected for the cylinder head is cast iron with sigma all H is equal to 43.33 Newton per mm square. Already we have find out the sigma all is equal to, here, allowable tensile stress, thickness of the cylinder liner. Okay, then let us take K1 is equal to, this value we want to the take from the table. K1 is equal to 0.35 as per the material, you will get that value. TH is equal to 0.35 into 135 into root of 4 divided by 43.33. You will get the TH, thickness of the cylinder head, is equal to 15 mm. Then number of stud, it is denoted by Z or N. Here we are using the notation N. We have seen the formula. The number of stud N is in the range of D, capital D divided by 100 plus 4 less than or equal to N less than or equal to D divided by 50 plus 4. If you are putting that, then you will get 5.35 is less than or equal to N. N is less than or equal to 6.7. Then you should take next digit, N is equal to 6. Number of studs, we require the 6. Diameter of the stud, it is denoted by the dB. How to calculate that dB? We know that the allowable tensile stress for the stud is sigma th syt divided by nf, 380 divided by 6. You will get the 63.33 Newton per mm square. The core diameter of the stud is given by dc is equal to d into root of p max divided by n sigma th. If you are putting the value, then you will get the dc is equal to 13.85 mm. Then nominal diameter of the stud, db is equal to dc divided by 0.84. Then you will get the 16.48 mm or 18 mm. db is equal to 18 mm. Then 9, diameter of the stud, pitch circle and flange. How to calculate that diameter of the stud, pitch circle, dp, diameter of the pitch circle, stud pitch circle, and flange, diameter of the flange is denoted by the do. dp is equal to d plus 3 db. You know the relation. Then you will get the dp is equal to 189 mm, and the outside diameter of the flange is do. You know the relation, dp plus 2 db plus 12 mm. You will get the do is equal to 237 mm. Then we want to calculate the pitch for studs, pbo, pitch for the stud. pbo is equal to pi dp divided by capital N. Capital N we have calculated, n is equal to 6. Pi into dp 189 divided by 6. You will get the pbo is equal to 98.96 mm. The minimum and maximum permissible value of pitch are, you should check that value. Then with the help of that value, pitch of stud will be satisfied. pbo minimum is equal to 19 root of db is equal to, you will get the 80.61, and pbo maximum 28 root of db, you will get the 118.79 mm. Now 80.61 is less than pbo and pbo is less than 118.79 mm. Hence condition of the pitch of the stud is satisfied because this 80 is less than this minimum value is less than pbo and pbo is less than maximum value. That's why this condition will be satisfied. Student, you should remember the formulas, this 10 formulas. Okay, this type of numerical will ask for the end sem examination for 18 marks or 16 marks. You will get the all the formulas in that numerical. This is very important. Okay, then next numerical we will see on the basis of the connecting rod. Okay, yesterday we have seen the design of the connecting rod. Okay, construction working of the connecting rod, then how to design the small end and big end we have seen in the yesterday's lecture. Determine the cross section of the I section of connecting rod for single cylinder IC engine. Use the following data for the engine. Then see which data is given. Piston diameter is given. Piston diameter is equal to 100 mm. Mass of reciprocating parts 2.25 kg. Length of the connecting rod 300 mm. Stroke length 125 mm. Speed is given 1500 rpm. Maximum explosion pressure 3.5 Newton per mm square. This is value is given for Pmax. Factor of safety, again FOS is given 7 or NF is given 7. Then density of the rod material 8000 kg per meter cube. Density, mass upon volume, that's why you will get the unit kg per meter cube. Yield stress in compression 330 MPa. Assume width of the section as at, okay, depth as 5t, where it is the web thickness of the I section. How to calculate that? D is given, say piston diameter is denoted by capital D 100. Length of the connecting rod L is given 300 mm. Then mass of the reciprocating parts MP is given 2.25 kg. Then RPM is given. Okay, speed is given, n is equal to 1500 RPM. Then maximum explosion pressure is given 3.5 P max 3.5 Newton per mm square. Factor of safety is given 7. Density, it is denoted by the rho is equal to 8000 kg per meter cube. SYC is given 330. Yield stress is given. That's why SYC in compression SYC is equal to 330 Newton per mm square, and assume width of the section as 40. B is equal to 40, and depth means we can say the height is equal to 5t, where it is the web thickness of the I section. Crank radius, you know how to calculate. That radius is denoted by R and is equal to length upon divided by 2. Okay, which length? Stroke length. Stroke length is denoted by the capital L, and length of the connecting rod is denoted by the small l. Then you should use the capital L divided by 2. 125 divided by 2 is equal to 62.5 centimeter. Then see the first you should selection of the cross section. Here the cross section is given I section. See shown in figure. See the figure. Then flange thickness, web thickness 1. We are assuming here flange thickness is 1 and web thickness also 1. Width of the flange B is equal to, they have given 40. I have shown in figure, and H is equal to depth of the section, H is equal to 5t. This is given data. With the help of that given data, I have shown section A. Then second, the area of the cross section AC is equal to, how to calculate that area of the cross section? We have taken the cross section C, then 2 into 40, this B, into again T, thickness of that flange, okay, plus 3T into T, you will get the 11T square, area of cross section AC. Then moment of inertia of the cross section, you know how to calculate the moment of inertia. We have learned in the SOM subject IXX and IYY. Here we want to take the IYY cross section. 1 divided by 12 BH cube divided by 12. In IXX section we have calculated BD cube divided by 12 because of rectangular. Okay, here is also section is given rectangular. That's why B width into height cube divided by 12 minus 1 divided by 12 B minus T, this B minus thickness, okay, into H minus 2T cube, because of 2 times T is there. Okay, we are consider here. Then you will get, when you solving that, IXX is equal to 34.9167 T raised to 4. This value we will get in mm raised to 4, and IXX similar way you will get the 10.9167 T raised to 4, okay. Then next, radius of gyration, it is denoted by KYY. Yesterday we have seen one numerical also, same thing is given. Radius of gyration, how to calculate again? K square YY is equal to IYY divided by A. Then you will get the KYY is equal to 1.7816 T. Then Kx square is equal to Kxx is equal to, similar way calculate that, 0.9962 T you will get. Then next, equivalent length for the both end hinge, LC is equal to L is equal to 300 mm. Both ends are hinge, you will get the same value. Then maximum gas pressure, this equation how to use? We have given the 4 conditions. See, LE is equal to L, equivalent length. We have seen also this condition in SOM subject. Okay, from the buckling of columns, there we have seen 4 conditions. One end is fixed, another is free. Again both ends are fixed, both ends are hinge. Okay, depend on that, L is equal to 300 mm. Then maximum gas pressure F max is equal to pi by 4 d square. You will get the F max is equal to 2748.94. Maximum pressure is given 3.5. Okay, and next is a buckling of the connecting rod for the plane of rotation. To calculate NF F max is equal to SYE into AC divided by 1 plus alpha LE divided by KYY square. Alpha is equal to 1 divided by 7500. Okay, with the help of ranking equation, again same unit, buckling of columns, we have seen yesterday the ranking formula. We are using here that ranking equation and find out the capital T value. This is 56.56 or minus 7.09. Okay, this both value we will get. T is equal to, we will get finally 7.6 mm. Okay, then next is the dimension of cross section. Flange thickness T is 7.6 mm, web thickness 7.6 mm, width of the flange B is equal to, they have given 40. Put the value T is equal to 7.6, you will get the 30.4 mm, and depth of the section H is equal to 5T, 38 mm. Then 9, check for buckling in a plane perpendicular to plane of rotation. How to check that? Again you should use the buckling load in a plane perpendicular to the plane rotation. Okay, plane rotation. Again use same ranking formula and calculate the value. Then check the available factor of safety against the buckling in plane perpendicular to the plane of rotation. NFC is equal to FCR divided by F max. NFC is equal to, you will get the 7.25 is greater than 7. Hence the connecting rod is safe against the buckling in plane perpendicular or plane of rotation. You should calculate here two value, FCR value and F max value. F max value. With the help of that you should check the value of that both. Here kxx also we will get that we want to the calculate that value. Okay, both value if you have taken the ratio, then check which is the greater value. Then next last is a check for the transverse bending stress or whipping stress. The transverse bending or whipping stress is calculated at speed is 1500 rpm. W max is equal to 2 pi into 1500 divided by 60. Then rho is equal to 8000 kg per meter cube. Okay, then section modulus about the axis of YY. ZIYY is equal to IYY divided by 2. Put the value, you will get the answer 6132.5 mm cube. And ZYY is equal to 6110 raised to minus 3 meter cube. We will convert that in meter cube. And calculate sigma BW is equal to rho into AC W square R into L square divided by 9 into root of 3 ZYY. Put all the value, you will get the sigma BW is equal to 7.38 Newton per mm square. Again check the allowable bending stress SY divided by NF. You will get the 47.14. Then check both values sigma BW and sigma all. Sigma BW is less than sigma all. The connecting rod is safe against the transverse bending stress. Guys, you should solve that three numericals. You will get the all the formulas from that three numericals from the unit number 5, design of IC engine components. With the help of that formula you can solve all the given numericals, okay, in the examination. This is very important because you will get the 16 or 18 marks question on the unit number 5. Today we have completed the unit number 5. Next lecture we will going on the unit number 6. Thank you.